Reminder to all our speakers to please stick to the time allotted to them, which is about 10 minutes. Request you to please try to wrap up your presentations around 8 minutes or so. Perhaps you can take up some questions towards the close, towards the end. I will hand it over to our session chair, Mr. Zuchi, to steer this discussion ahead.
Right, thank you very much. I had a presentation, so somebody will run it for me. Yeah, am I audible? Right, thank you very much. So, yeah, so I spoke about some of the areas around submarine cable industry and business and ecosystem in the morning. So today, at this time, I will spend some time in taking all of you through the key components of the submarine cable ecosystem and give you some further insights into it. Can I go to the next slide, please? Can somebody run the slides, please? Oh, or this is it, okay, okay. So before I do that, let me give you a brief intro on NEC India. NEC India is present in this country for more than 60 years now, and we are doing a lot of stuff besides submarine cable, a lot of technologies and solutions that we offer for the country. And we have more than 1,400 employees, and we are present in multiple locations. So as you know, submarine cable systems take care of majority, if not the entire global data communication, and that's where they are very important for anything we do online. And this is a typical layout of any particular submarine cable system, consisting of the cables itself, which can run for thousands of kilometers and work as deep as 8,000 meters, 8 kilometers under the surface of the sea. There are repeaters and branching units, which are important for amplifying the signal on the way, because submarine cables run on optical data, which have limitations in terms of going up to a certain distance. Then there are the terminal station equipments and power equipments to power the hardware, the active hardware that is deployed along the route connected with the cables. Obviously, we have to use various marine infrastructure like cable laying vessels and other equipment that is necessary for laying the cables under the sea. So all this can be divided into three key components. First of it is the wet plant, as the name signifies, is something that goes into the waters, consisting of the cables, repeaters, branching units, various joint boxes which connect various types of cables. There are several types of cables that are deployed depending upon the location and the depth where the cables are actually deployed. Deeper the water, lesser the protection around the cable, and shallower the water near the shore, the protection is maximum, obviously, because the possibility of any damage to the cable systems are more in shallower waters. Then you have the dry plant, that is the infrastructure that is deployed in the so-called cable landing stations, where you have optical infrastructure, where you have power infrastructure, and you have the land cables connecting the submarine cable getting terminated at the shore and leading it into the cable landing station. So each cable landing station and the line terminal equipment deployed for enabling the communication is capable of handling hundreds of terabytes of capacity. And then the last but not the least most important element is the marine operations, which is to do with anything around laying of the submarine cable systems into the sea, as also the maintenance. It's a very complex procedure that is followed in terms of selecting the proper route, which is safe for the cable to operate over decades, and involves complex marine engineering and deciding how to lay the cables, what type of cables to lay, and select the timing of laying the cables also, because these cables are laid only at the time when the weather allows. The marine operations are pretty much dependent on weather. You cannot do these operations during periods like monsoon. So to that extent, in India, there are limited weather window available for conducting such operations, both on east coast as also the west coast. On the west coast, it is little wider, typically from October to May, whereas for the east coast, it is narrower. It is somewhat around end December, early January to May. So east coast presents a bit more challenge in terms of the available timeline for deploying submarine cables, though, as I mentioned, east coast is more friendly to submarine cables in general as compared to west coast. Now this is important. As I mentioned in the morning, 2020 was a pivotal year in submarine cable industry, and this slide explains it in a little more detail. You can see post 2020 the amount of explosion in the data traffic that has happened globally, and we are seeing a consistent growth rate of around 35% annually. It's unprecedented, and that has given a rise to demand for submarine cables. So there are, if I may add to it, 2020 was a pivotal year post, everybody knows COVID, and people started working online and things changed. And this next pivotal year, or the next pivotal period, is now, which will be driven by AI. So these are the two milestone periods, I would say, that will define the progress of submarine cable industry. Now with that, the development of the technology and the cables itself has undergone a lot of change. Pre-2020, you had submarine cables capable of supporting, let's say, 4 or 6 fiber pairs and tens of terabytes of capacity put together. That's changed tremendously, 100-fold increase, right? And you now have fiber cables with at least 12 fiber pair and up to 24 fiber pair, and each fiber pair capable of handling much more traffic than in the past. One fiber pair is now able to support traffic which an entire cable was able to support some time back. So that's a tremendous increase in the bandwidth, and it's increasing further. And that's the key focus for NEC in terms of developing the hardware and the technology necessary for supporting such a tremendous increase in capacity, which I will explain in the next slide. So any submarine cable project or the ecosystem, again, can be classified into 3 components in terms of the support of capacity. The first component is the cable itself. The second component is the active hardware that goes into the wet plant, namely the repeaters. The branching units also included over there, but primarily repeaters. And the third component is the terminal equipment. If you look on the left-hand side of the picture, that is how things used to be so far. Single core fiber pair. One cable consisting of fiber pairs handling only one core. So in order to increase the capacity, you can do 2 things. Either you can increase the number of fiber pairs within the cable, or you can increase the capacity of traffic that can be supported by a single fiber pair. In order to do that, one way is to have multi-core fiber. That means multiple cores into the same fiber pair, and that's what we are doing. So we are having multi-core fibers in our roadmap for enhancing the capacity of submarine cables. And today, these multi-cores are uncoupled, and going forward, we can have coupled fiber cables where the signal can basically interchange between the cores, enhancing the capacity. The second part is related to the repeaters, which have to be designed to support this multi-core ecosystem. And currently, we have the same type of repeaters with an additional device called fan-in, fan-out in order to enable transmission through the multiple cores. And going forward, we will have the repeater units which are based on multi-core technology itself, the components inside the repeater. And for the last part of it, the terminal equipment, we are using the MIMO technology, which means using multiple, you see, in the optical domain, you have the wavelength. You use wavelengths, or channels, so-called channels, as in the wireless, you have frequencies. In case of optical domain, you have the wavelengths. So we use multiple polarizations, and we are going beyond orthogonal polarization in terms of increasing the number of channels that can be supported within a wavelength. There's a lot of technological development that needs to take place to support that, and that's the way we are trying to increase the capacity of the electronics and the cable that is going to enable high capacity future submarine cable systems. Yeah, again, as I mentioned in the morning, we have completed 2 projects for Government of India in India. One being the Chennai and Andaman Nicobar Island cable connection, which was completed in 2020. And it connected 8 islands of the Andaman Nicobar with Chennai. The second system was Kochi Lakshadweep Island connection, which connected 11 islands of Kochi, Lakshadweep with Kochi. And the difference between the 2 systems is the architecture. As you can see, we learned on the go. The architecture for the Kani is linear. So that means if there is a damage to any of the cable system, one of the islands will get isolated, or God forbid, if there is a damage to the trunk, all the islands will be disconnected. Fortunately, so far we have not faced such situation. Primarily, again, as I said, East Coast is friendlier, and we adopted a ring architecture in KLI, where it has a protection inherent because of the architecture, because of the configuration and the design. And we also built a international submarine cable system called MAST. It was completed in 24, connecting India with Thailand, Malaysia, and Singapore. So all these 3 cable systems have enabled my company, myself, my team to get deep insights into this complex domain. And today, I can proudly say that myself, my team, my organization is the most qualified set of people in India when it comes to submarine cable system deployments. That's a proud achievement for us. Thank you very much. Hello. Okay, I've also been given the responsibility to chair this session. So taking that responsibility, let me invite the next distinguished speaker, Philip from Meta, and make his presentation.
Thank you, Ashutosh. And do you hear me okay? Thank you, everyone. And definitely it's good to see all the industrial friends, fellows, and partners that we are working together here in India for this future roadmap of our robust, resilient subsea infrastructure. There is a saying that who control the person, control the future. So thinking about we are the people. We are the group of people that is kind of structuring, shaping the future of the connectivity for India and how we enable a digital infrastructure hub and have a better resilience, a robust network over there. So last week is a very good kind of AI summit, and I think everyone is kind of excited about the AI infrastructure, what is going to change the world. And India is being the center of all those connectivity that we are working towards. We are actually seeing that AI is powered by connectivity. So we are the one making the connectivity, and that is more than ever that connectivity is playing a most important role in this era. And to catch this wave, we need to work together, and definitely time to market is the most important thing. So I think several keynotes kind of people talking about the submarine industry is getting longer and longer to getting a fiber to be a PA. So we will be in the position that we should be supporting and then see the way to improve the efficiency. We should be the team to support more cost economic and diversity around the group for connectivity to make it attractive for the foreign investment, right? Because at the end of the day, we want to making sure that we have the right capacity to support the people to connect, and submarine infrastructure is definitely the key things. And to start with, let's see. Okay, so the first thing I will be looking from the investment point of view, and also some technical kind of things to support the investment for the resilience. So we are looking for fast forward for a few years later. It's not only now, but longer vision around that. It surprised me when I kind of coming into Meta and then looking after the India market. India is a huge continent. There is a 7,800 kilometers of the coastal line. But we are only having 2 international gateway. As of today, still, that the major subsea gateway is Mumbai and Chennai. I think definitely to shape the future, to have more robust network, we definitely need to build more. And I'm happy to seeing that a lot of our fellow have industry peer that they are already announcing different things and then looking into that. And we, as an industry, should work together to provide more connectivity to different locations to enable more diversity. So there is a lot of room for more diversity that is kind of interesting to like going into Dhaka, Vizag, Machapallam, Kochi, Mumbai, diversity for more locations like Allahabad, Gujarat. So those are the locations that we are seeing that is important for the future on that. So if you look, zoom in, right, Mumbai and Chennai, they are all concentrated into a very little corridor, and then the price of getting into a CLS or backhaul fiber is very expensive, right? So we need to see how to improve the kind of strategic development of a new subsea gateway, and then it also helps us to enhance national connectivity and resilience. If you're thinking about the way that we are doing is connecting the people, and it shouldn't be only Mumbai and Chennai. It should be getting closer to our end user, and then that is our goal for that. And secondly, if we're looking into that in a more detailed resilience diversity level, we need to get an alternative route from what we are seeing today. So this September, we are seeing a huge fiber cut in the Red Sea area. So it's kind of making the internet kind of choking, and is kind of getting a lot of challenge. What make it maybe a potential problem is that if you're looking about India West, we are all going to West Sea right now. And in India East, when you're going to Singapore, for example, it's always going to a Malacca Strait, right? So we need to thinking about how to diverse from there. And that is what and why Meta is doing the Project Waterworth to connect to a different location, increase the diversity and resilience from the end-to-end connectivity globally. And more than that is, if that is India to become a digital hub, that need to be connect to more continent. As we mentioned, it's not only supporting the people in India, it's also connecting the people west of the world. So it's kind of obvious that it's connecting to Africa, Australia, Southeast Asia is the way of doing things moving forward. And definitely, another thing that I think is a challenge right now, but we hope to see that is resolved in the next few years, is definitely reliability, right? It's not only talking about subsea reliability, but it's also talking about the front haul protection, scalable, stable underground fiber, and shore end protection. We are seeing that because of our concentration in Mumbai and Chennai, and a lot of location is kind of because of a monsoon, global warming, there is a lot of challenge in the shore end erosion. So we need to find a long-term solutions, making sure that we have the right resilience to shape the future. And when you're thinking about a stable underground fiber network, it will be actually helping us to have more simple solutions. And the limitation right now is that when we're selecting a CLS and how to connecting into a major data center, the fiber connectivity is a constraint. So that is the area that we should improve because of the fiber cut, fiber loss. If we can improve that, it actually enables us to have a more optionality, right? If you're thinking about why people are connecting only in Mumbai and Chennai, there is a reason. Because the terrestrial network is not able to support the right growth arrangement, right? If we have more options, a better quality of fiber, it actually reduces the number of protected route, and also we have more options to go to Gujarat, and then also going to other locations, even in Chennai, we can going down to further locations like Surisuri. So those are the locations we should be enabled to have a more and better diversity around the area. And definitely scalability, right? So we are looking into a lot of as the speaker talking about earlier on, Google is building a 1 gigawatt data center, right? So what they're doing is that need to have a modular infrastructure enabling the growth. And what we are seeing in the future is that it's not the aging infrastructure that we are seeing right now, because the CLS right now existing is not able to support megawatt cable landing station. What we are seeing in the future is that we will have multiple 16 to 24 fiber pair system in the region, and that is connecting in the CLS. If the CLS is a limitation, then it's kind of limited our growth. We need to think about a scalable solutions to put together on the connectivity so that we can have SLT in the place that we like to, and then in the express highway to go back to our people in the center of India for that. Certainly, and other things that to make scalability easier is the licensing and regulatory regime. Another thing that we will be advocating is always to speed up the time to market, which is essential, is how we control our way of doing things. Coming from a content provider perspective, we are seeing that we are doing something quite unique compared to the other people. We want to build something that maybe only fit our business case, so we want to making sure that we have the right support and use case for ourselves. And definitely, if we can enable the captive use kind of connectivity, that will be help us to improve the logistic and things. Right now, the challenge that we are seeing is a long lead time. But if we are not helping to resolve the problem from the OEM, from the cable manufacturing, from permitting, for all those elements, we will be slower, and then we will be behind the other people. If we want to control our destiny, the key area of focus is definitely we need to have the scalability, reliability, the marine diversity, and the landing diversity over the area so that it support our future growth. And definitely with all those optionality built in, that will make our life easier and then definitely attract more foreign investment into India. So that concludes my presentation. Thank you so much.
Thanks, Philip, and thank you very much for being bang on time. Thanks a lot. Let me now invite Ashish Ahuja, founder, CEO of Sloka Partners.
Hi, good afternoon, everybody. First of all, thank you to BIF for giving this opportunity to present us and our perspective on this digital infra. And also, it's so lovely to see so many industry colleagues at one place. It's a privilege to be here to meet so many of you. Just a quick intro. Sloka Partners, we are a pool of global experts in digital infra, headquartered in California, US. with presence in 7 countries right now, with 13 senior executives and a dynamic team in India supporting us. We do strategy, we do execution, we do investments in digital infra. And we do develop some new projects and ideas to work with people like you, how to shape the upcoming projects or technologies to make things easier for all of us and to support this AI rush which we are going through right now. India is epicenter of the digital infra, if I can say. I don't know how many you track, but India is the second largest digital market after US. I have been privileged to be part of this India journey since the day first 2 Mbps internet link landed in India. We were sitting in the same building in VSNL in Fort. And till date, it excites me every day what is happening in this landscape. And we do enjoy this working together with passion in this market, though we work all the global markets as of today. Viksit Bharat, quick snapshot, you all are aware, but quickly, subsea cables, we can cover a lot. We do digital infra covering from data centers to subsea cable to cloud infra, but as requested by the team here, I would confine more of subsea cables for this session. So more than 98 or 99% of India's traffic is dependent on subsea cables. We are witnessing that the international capacity demand is doubling every 2 to 3 years. We have more than 1 billion users of internet right now in India, and with another 300 million to come in next 3 years online as well. The digital transaction scale is enormous, with $21 billion kind of a transactions on a daily basis. It's enormous. You can't find it anywhere in the world, I can confirm to you. And it works so seamlessly that we don't even bother how that Paytm works. But behind the scenes, the people who have been building that digital infra, I think they deserve a lot of applaud to make that seamless, whether it is the data centers or compute engines or the subsea cables at the back of it. Though most of you are well familiar, but India's subsea landscape, 18 cables landing across the 5 to 6 cable landing station, with upcoming cable landing station in Vizag, Machilipatnam, and Digha already under progress. Already more than 5 systems. So the white ones are existing, blue ones are under construction, and the orange ones are announced. That's how you can read those cables there. But at the same time, all this momentum has developed in the recent years, and there's a long way to go. More than 60% of the existing cables are getting closer to the end of life. What does that mean? We need to build even faster. Then, even today, though some of my friends may not like it, and we are trying to be neutral perspective here. We do work with telcos, we do work with hyperscalers, we do work with investors, we do work with other content players as well. So what we are trying to convey is an unbiased perspective of what the market needs right now. So even today, this market is still driven as a controlled cable landing station regime, if I can say that. We say it's an open cable landing station access, but in truly, there's no infrastructure as a service provider in this market. Whoever provides the connectivity is a telco with a license. There's no concept of infra versus service provider layer being separate as of now. And the scale which this country needs to build, I think it is healthier if we open those gates and allow the infrastructure providers to come in, besides the service providers continue to do their job of service provisioning. Private capital is waiting to enter into this country. Data centers have been flooded with private capital, but subsea cables not yet. The only contribution of subsea cables so far is from hyperscalers, and I have been privileged to be part of that journey as well. And why is that not happening? The reason is the regulations as well as the tax regimes are not so conducive for somebody to put few $100 million or $1 billion in a subsea infrastructure if they're not the users themselves. That needs to change. And finally, from a Viksit Bharat perspective, the vision which we carry or which the PM Modi has been advocating, there has to be support from the government in areas of infrastructure development where it may not be interesting for the hyperscalers or the builders to build. But India, as a population of 1.4 billion, needs that. So whether it is a single window clearance, whether it is use of the Digital Bharat Nidhi or USO fund, there's a lot to be done, including cable repair vessels which are not available. There's still a lot of legacy to vessels to come in and repair into the India ecosystem. So there are areas where we certainly need a lot of things to be done. Quick summary, what's changing? You have witnessed it, I'm just summarizing it for you. What has been the regime so far, what is gonna be the new regime, and what is the impact of that? We used to work availability-based service, 99.9% full stop. That is not a norm anymore. The user wants performance. They simply say, I need to have this impact of the service level. I don't know what works in the behind the scene. What it has led to, there has been a lot of application providers which are even able to monetize better than the infra players, including the cloud for that purpose. That's a norm now, without any question. The number of IPLCs we used to run are now getting dwarfed against the cloud capacities running between the continents. That's a straightforward answer of that. Cable landing station to cable landing station regime is not the norm. Norm is now data center to data center, because that's how the traffic flows. So what does it mean? That means you need more edge and compute with CLS at one place. And that's what is happening, and we have a couple of projects already in the pipeline working on the same to make that compute and connectivity together at one point in many parts of the geographies. Traditional NOCs don't work anymore. As of now, you need to have the automation. And as a skill sets for managing the network, along with SREs to NOC engineers to this, with the AI supported, is getting automated. And now, you have to have a different hybrid skill set people to manage this show for you. And infrastructure is gonna run as a code, no longer the wires. This is evident without any question. So whoever is in this business need to embrace that software part of the story for your infrastructure management without any options left out. Consortium cables, we started our life or world with CMEVs of the world in the 30 years back. Today, because of the time pressure to build as well as the economies and the users being dominant, it's a private cable story right now, which has driven 70 to 80% of the new builds. That means what? Infrastructure is also seen as a competitive advantage for those deep-pocketed players who want to invest from a long-term perspective. Best effort SLA, repair times, nobody wants to talk about. Everybody wants to say how many route diversities you have, what is the strict SLA I can achieve. We talk about 5 nines these days to be delivered. That results in multiple cables as well as resilience by design. And the last point is same. We are not talking about layer 1 circuits anymore. We are talking about layer 3, point-to-point, as well as global mesh and SDN-based story. What are the new opportunities? As we evolve, it also provides us a lot to do new rather than just looking at the traditional world we have been looking at. As I earlier said, cable landing station come edge data center are going to be the norms. You will find less and less standalone cable landing station buildings emerging. They will merge into the compute platform as well. Domestic subsea cables. India has been talking about Jalmala a project for 3 decades. I think it's a time to make it a reality now, to make those coastline subsea cables functional and give access to each and every corner of this country to a highway for international as well as the domestic. Because the terrestrial still struggles at occasions, and that subsea gives that answer. Fiber sensing. We are involved in few projects right now, including India and other geographies. There's an immense opportunity here in terms of the subsea observatory data, as well as for repair ones, which are opening the doors for new players to come in. Happy to talk offline if somebody is interested. Similarly, insurance and repair vessels. There's only one company in the world currently talking about subsea insurance. But if we meet again here in a few years' time, I'm pretty sure there will be a bunch of them who will be talking about this. Repair vessels are common, but India doesn't have an Indian flag repair vessel even today, despite being the epicenter of the digital growth right now. We have been talking to the government or agencies, and there's a good effort going on, and hopefully by the time we meet again next year, there will be a project which will be running here, and some of the stakeholders are in this room who are very keen to participate and help in that journey. And finally, from a digital infra, you need the SEZs or international Sorry, Ashu, I'm going to take 2-3 minutes more. So transit hubs or SEZs are norms which have to be available for international people to come to open the data embassies and sovereign cloud, etc. I will quickly run through this without spending time. Government is very important in this whole journey as the catalyst. The single window clearance is needed to build infra. CLS to be declared as a critical infra. Sovereign digital corridors need to be opened up. And the BharatNet subsea expansion, which I was just talking, deserves to be supported by government. And India's submarine cable policy is the right time to open up that and make it available for stakeholders to participate. As a journey, if I see how India's future will look like, and this is probably the last slide of this one, we have the stakeholders, which we all know, telco, hyperscalers, regulator, government, and capital funds, starting from the new cables and private capitals to come in right now with government-supported infrastructure projects, followed by the policy framework to attract new investments into this space, and vision for India to become one of the top 3 transit hubs of the globe. I think that's how it should look like, and we are capable to do so if the policy framework helps into that journey, which eventually will land into the sovereign data center clusters, data embassies. They will not be able to flourish if there's no connectivity in a seamless manner available. As a team, what we have done so far, we have been privileged to have very senior people with us. We have been involved in building 20 subsea cable projects around the world, sitting in different organizations. We have developed the project in 5 continents. We have been involved in more than 1 gigawatt of data center capacity build projects. Altogether, we bring 150 years of experience, and we enjoy a great relationship with the ecosystem from customers to hyperscalers to OEMs to investors. And we are happy to be partner in anybody's journey for digital infra if you want to build together. Thank you so much, and sorry for taking 2 minutes extra.
No problem. Thank you, Ashish, for your insightful presentation and putting forward some very useful suggestions. I think we'll have time to discuss about that in more detail later. Now, let me take the opportunity to invite Mr. Neeraj Shankar, CTO, Constel.
So very good afternoon, ladies and gentlemen, friends and colleagues. I'm audible on the backside. So today is a very, very unique situation when I look at the panel. It's a very unique one. We have 3 members in this panel who were part of the VSNL journey for the internet launch. The internet which was launched in 1995, 15th August. We have Ashish, the good old young days of Ashish. He was marketing lead for the VSNL, and Somesh Gaur was handling the subsea cable system. I was the project director for the project. So big round of applause to all three of them. Well deserving. I thought it came to my notice, and we are part of the Broadband Forum, and good to see how internet has evolved over the last 30 years. The other point I just want to refer is, the first submarine cable capacity, which was commissioned for internet services way back in 96, 97 on the FLAG. FLAG was the first consortium cable which gave a STM1 connectivity, 155 Mbps way back to 96, 97. So you can connect the dots now. The journey started with STM1, and we're talking about multiple cable landing station, multiple subsea cable systems. So with this, I'll move on to my story. I'll need to pause, sorry. So I think we have attended the AE Summit. Sorry, my voice is bad actually. And we have seen various kind of news items and various kind of communication and announcement made actually. If you look at government of India is eyeing on 200 billion kind of investment coming in, pouring in into the country. So what does it mean actually? So $200 billion, Philip has announced, made up part of the story. We heard Ashish, earlier we heard, in terms of Google, what they are trying to do it actually. So what is going to happen is, while we'll have many landing stations, and we talk about diversity, both on the marine side, multiple cable landing, but end of the day, you need to carry this traffic back in India. If you look at the Indian scenario, most of the fiber infrastructure, which is long-haul metro, has been dated 20 years back, 25 years back now. As a Constel, what we have done is we built our own fiber network, both in metro environment, Delhi, Chennai, Mumbai, Hyderabad, and also we built the low latency network between Mumbai to Chennai. So for us, the focus area is the AI corridor of Mumbai to Chennai. So first cable we built, low latency, high capacity, 2 docks, multiple fiber, and we tested the 1 terabit capacity between Mumbai to Chennai. And if you look at it, what we're building, that we're connecting all the DC, the data centers, almost 100 plus data center and cable landing station across the country on multiple fibers. We have almost a 3-path, low losses on the fiber, and we're connecting all the data centers as well as cable landing stations. Here, just to kind of recap here, what we're doing is we are basically looking at the data center. If you look at the market we're serving, segment we're serving, hyperscaler, data center, cable landing station, telco is ISPs and OTT. Now, this is an important slide for us, and this is what I want to kind of brief and talk about it. If you look at this slide, we already built Mumbai to Chennai, our own fiber network, 2 docks, 96 fiber on both the docks actually. If you look at it in Mumbai, Chennai, Hyderabad, our own 4 docks kind of infrastructure built actually. What I'm going to say, when Philip talked about 16 pair of fiber, 20 pair of fiber on a submarine cable system, finally you have to carry this capacity back on our own build network. I mean, operators have to offer fiber, whether it's the name of the MOFN, Managed Optical Fiber Network, or otherwise you need that kind of fiber and resilient and robust, covering whole of the country actually. So why we spoke about Mumbai to Chennai, as I speak, we are covering another project called Dhanush in the process of execution, again connecting Mumbai to Chennai, Hyderabad, back to Vizag. So Vizag is also on the list as well. And if you look at Delhi, Chennai is already live for us. Delhi, Mumbai is live. So we've got enough and more capacity across duct, across fiber to serve, to carry all this capacity from the cable landing station to data center. One of the topic is very clearly, and Ashish touched upon, while you have a lot of AI in terms of model, which is being worked in data center, but the traffic has to go back to the edges. Edges is where you need to connect to the data center. So who will connect, how are we going to connect it? So this is where we chip in as a Constel. We connect all the data centers, all the landing stations, and all the services, so to speak. So if you look at as we speak, we covered 13 cities, almost all metros, so to speak, 100 plus data centers and cable landing stations. And we almost like 34,000 kilometers of fiber is a combination of our own build and a combination of OPGW. Bottom line is we want to offer 100% of time between Mumbai to Chennai, for example, on a 3 different diverse path actually. And if you look at what we're also serving, the low latency, the shortest path, apart from redundancy, the most important aspect in this game is the shortest path. So Mumbai, Chennai, if you look at it, 400 kilometer, shortest path you can get, 14 millisecond kind of latency you are getting on that network. So diversity, robustness, resiliency, plus low latency and high capacity. I said earlier, we tested 1 terabit between Mumbai to Chennai on our network without regeneration. The important thing is the losses are controlled. Without regeneration, we can pull it off 100 terabit capacity on Mumbai to Chennai. Moving on in terms of some of the design parameters, just to kind of bring up to the speed is, we are looking at best of the fiber infrastructure we're using, best of the ducts we are using, like Duraline, for example, and the depth we are putting, almost like 2 meter depth when we build our own network between Mumbai to Chennai, second path between Mumbai to Chennai, or metro environment, because this is where you live first time, and you want this network to live for next 20, 25 years time. And obviously low latency, I touched upon in terms of resiliency and robustness. Then on top of that, if you look at it, the whole model of corrective, preventive maintenance, and so on and so forth become very critical. So we are offering a bundle end-to-end story from the quality of infrastructure, capacity, as well how we operate and manage the operational process. Our own operation team on the field, on the ground, they are making a big difference in terms of MTTR, SLA, KPIs, what Ashish was touching upon. Moving on, in terms of, you look at this as part of the story, and I think Philip and Ashish both covered it, so I will not kind of touch upon, but bottom line is we need to have a geographical diversification, and Philip did cover as part of his presentation. Good to see that, because I remember we had a situation back in 2011 and 12 when I was part of Datacom in terms of operation management. We were on the verge of getting isolated. There was only one cable when we had an earthquake in Japan, and we had a sabotage in Red Sea. India was on the verge of getting isolated. There was only one cable which was carrying traffic for whole of the country. So it's very critical that you need a diversity, you need a route diversity, and same on a similar line. We also need a diversity within the country. I mean, you may have multiple cable landing in multiple part of the country, but at the end of the day, you need to carry the traffic back to all the data centers and all the edge part of the story. In terms of redundancy and route diversity, we touched upon, with multiple cable landing station, seismic zone we touched upon, we talk about, the political situation, geopolitical situation, and the rapid restoration. I will not touch upon much on this topic, but Ashish and Philip both have covered it. It's a critical one. Apart from seismic, the sabotage part of the story, how we really ensure our own marine infrastructure is critical here. And I touched upon in terms of sabotage, which is the next one, cyber and physical security, is critical. I give an example. Twice we were on the verge of isolation for the country, so to speak. And the last one is, which is critical as India embark, and I think Ashish touched upon, we still don't have a restoration force. We don't have a ship for the restoration fiber. We still wait for 2 or 3 weeks for the ships to arrive to restore the fiber, either on the west side of India or the south side of India. So we still need to have our own fault repair ship, which can maintain and expedite the restoration part of the story. Moving on. So this is what you're talking about in terms of what we are offering, and is touched upon, very robust infrastructure, multiple pair of fiber. We dug it 2 meter deep, and less losses, high uptime, and all the mechanisms we put in place actually. So robust terrestrial network, efficient architecture. So in terms of architecture, we ensure that we have enough resiliency and we are able to leverage the kind of technology we are using it. Future ready in terms of expansion, etc. And obviously AI and data center. Not only we are looking at CLS and DC, but also as Ashish was and Philip was pointing out, the edge data center will do most of the processing. Hence the connectivity between DC and edge become critical and crucial. This is where we ship in and connect a whole lot of DC landing station as well as edge infrastructure. Strategic partnership, we are working with hyperscalers, the consortium partners, and we are open to help them in terms of building up a landing station in India, which is a neutral landing station, and everybody is welcome to join that. And lastly, not the least, the whole automation journey. We are in the age of AI and how we are leveraging AI for our own automation tools, and how we are ensuring that we make everything real time and work upon it. So this is what I want to cover as part of Constellation story, and thanks for your time, appreciate. Thank you for, I just want to talk. Thank you very much.
Thank you very much, Neeraj, and thanks for keeping it within time, even though you had requested me a little extra time. And thanks for leading us the memory lane from where we started and where we are today. It's a wonderful journey. Let me now invite Mr. Anish Kohli, Director, India and Head of Carrier and Service Provider Business, South Asia, Middle East and Africa, Telstra. And let me make a request to the remaining speakers to try and keep it a little under the time, because we may not have enough time for Q&A. If we won't have Q&A, please finish it off a little earlier, and maybe I would like to steal some time from you guys. Thank you.
Sure, thanks. Good afternoon, everyone. It is, of course, a great opportunity. Thanks to the BIF for this wonderful opportunity. Romans invented, it is said that they invented the lead pipes 2,000 years back. Okay? And that was, of course, to carry water from one point to the other. And of course, we know water is one of the most important elements. Life cannot stay without it. Today also, if we look at it, we are out of sight as an industry, but never out of mind. Because 97% of the cables on which the internet runs, that's never visible, right? It's all under the sea. But it is very, very important infrastructure. I am been blessed to be part of the organization called Telstra, which has been, I would say, at the forefront of investing in robust and resilient infrastructure, the cables, for a very, very long time, for many years. We have been operating and building the subsea cable systems and infrastructure, and it, of course, supports all the customers that we have, the hyperscalers, the enterprise, the telcos, the carrier segments, everything. Today, when we look at it, right, it's a it's a scenario where India's, of course, economy is booming. There is more than 1 billion eyeballs that are sitting over here, and there's a lot of talk about the robust infrastructure. I, fortunately, have been part of this journey for more than 2 decades with Telstra. And, of course, we heard the example from Neeraj on the first cable flag. Luckily, almost 30 years back, Telstra, via its investments, also had an investment in a cable which very recently got retired, CMEV3. Okay. So when, sometimes I ask this question, are we a young industry? Are we a mature industry? Or are we an old legacy industry? Well, of course, on one side you have cables which are getting retired, so that sort of shows we are getting old, but no. We are actually a highly matured industry because now we are at a tipping point where if you look at it, with the advent of AI and other stuff that's happening in technology, I mean the flow of data centers and all happening, I think the way now the cables are being built, and we heard, in the morning session from Meta as well, and we recently had announcement from Google as well, right? All that shows that this, firstly, is a very, very important industry that we are in because we are connecting continents and scaling clouds, right? And in fact, Telstra launched its Connected Future 30 strategy last year, which talks about doubling down on the core connectivity and infrastructure. So very much over the years, we have become an industry which is very, very important, maybe invisible to people, but very important. And of course, we know that we have 5 elements in this world, but there is one of the most important elements, which is data, without which we cannot live as well now, even if I would say that we have the 5 elements, but we don't know what to do if the 6th one is not there. This is just a, sort of story that Telstra has created over, many decades. We have invested in more than 30 cable systems across the globe. Some we own, some we are consortium in, some we are having lease capacities, IRUs, whatever, huge capacities. But most important is to connect. Now, going back to my point about the industry, see, when we talk about India, I still feel that India is still a young industry in terms of when we look at the cable ecosystem, right? I mean, globally, there are almost 600 cables, almost. I would say 575, 580 operational, some coming up very soon, etc., etc. India has how many? 18. So it tells us a story, right? A story of a big growth potential, a story of a big opportunity. One of my previous distinguished speakers, Ashish, spoke about the landscape, the regulatory, the landing station, the cable permittings, the ships. See, what happens, I mean, when globally a catastrophe unfolds, and we heard the example of an earthquake, and actually, I have myself seen personally all that happening because who gets the calls when cables go down, right? We face it from the customers, right? And we are doing our best in whatever our capability is. But it is very important that the country or the organization which is building the cables or having the cables has enough redundancies. That investment is important, the intent is important. As I said, today we have more than 38 cable landing stations where we have access, more than 400,000 kilometers of fibers. Today, as an organization, Telstra runs 869 TB capacity across the globe. That's a huge capacity. And of course, with huge capacities and investment come challenges. And one has to be ready for that as well, which is in last 4 years, I think, if we see, in fact, the number of cable cuts, I think, have gone up, more or less. I think everybody will agree with me. I was at the Capacity Middle East in Dubai a couple of weeks back, and there was a lot of talk about Red Sea, how to bypass, etc., right? A lot of the GCC countries over there are working in that domain as to how they can create those redundancies as well, because they want the local players are working over there. Similarly, when we talk about our country here, right, which is where we are currently, an incredible growth opportunity, the number of cables have to be higher. It was great to see that, now a new cable landing station is coming up as a location, because that's what has been missing for quite a while. Unless that happens, obviously the growth, you can't really grow to that level what you want to. So I think that's a big positive step which is happening. We as an organization have been into this business and have been doing a lot of management, putting a lot of, I would say, quality into maintenance of these subseas. Of course, India again would have a challenge currently of repair vessels. We heard about it in the morning also and recently also in this session as well. So, but again, at the end of the day, it's a lot of opportunity. Players, the foreign telcos, right? Today, thankfully, the licensing, earlier I remember we used to take FIPB approvals, etc. We started from there, but today a lot of things have eased up. Things have become quicker, faster. So that has helped scale, the whole, I would say, the ecosystem. For us, of course, we have multiple FBO licenses in more than 25 countries we operate in. We have more than 30 cable systems, as I mentioned. All this requires a lot of effort, a lot of intent, a lot of investment, and a lot of urge to serve the customers. And thankfully, I work for for an organization which does this. We have a great opportunity in India. I think if, certain norms could be eased up further, it would really help the overall ecosystem to India to become a hub for cables. I mean, today we are, 3% of the global cables are in India, right? Out of 600 approximately, we are talking about 18. So with that, I'll end here, and I would hope and look forward to this amazing industry, which is growing, evolving, and hopefully India will also become a matured industry in the cable space the way global cables have become, and we are young. We have a great opportunity to be there. So thank you.
Yeah, thank you very much, Anish, and thanks for your useful insights and also giving back a minute to us. Thanks a lot. Now, I would like to invite Mr. Somesh Gaur, AVP, Head Subsea Cable and Satellite Operations, Tata Communications. Thank you.
Good afternoon, everyone. Good afternoon, everyone. So I think, first of all, I'll thanks BIF for giving this opportunity. And this is the second time I'm attending this conference, and I was there in the last conference as well. So I'll be sharing my views, my experience over the last 25 years, and focusing into the subsea robustness and resiliency. And it is coming out of my experience over 25 years managing submarine cables. And I represent Tata Communication, and as a Tata Communication, we are not just building subsea cables, we are partnering with hyperscalers and other partners, as well as we are developing capabilities to manage the subsea network for other operators, not only in India, outside India as well. So we provide managed services to operators, subsea operators, and technical consultancy as well, and that is for the Indian operators, Indian cable owners, and also cable owners outside India. So I'll start with the background. I think we all know about Viksit Bharat Mission and the importance of digital infra. India's ambitious vision transformed the nation into fully developed, self-reliant country by 2047. It focuses on economic prosperity, social welfare, technological innovation, and sustainability, targeting a 30 trillion economy. So this is the background and the context of my presentation. And the importance of digital infra, be it we are talking about DPI, digital private public infrastructure, or it's a digital infrastructure which we are talking about AI, and we have been talking about AI in the morning session as well. So whether it's AI infra, data centers, or connectivity, which includes subsea connectivity also, that becomes very important part of this entire, Viksit Bharat mission. And the region, when we are talking about the robustness and resiliency, it becomes very important from this context of Viksit Bharat mission, and that is the topic of presentation that has been given to us. Now, the robustness and resiliency of these infrastructure become very important, and that needs to be discussed proactively because, you'll see in my presentation, anything that we are planning from the resilience perspective, that has to be discussed and decided very proactively. And I'll give you the context for that. And if you see the context for the submarine cables, and most of you may be knowing about this context, but there is something different in the subsea cables, which makes it very different from other infrastructure. And whereas the concept of resiliency and robustness is slightly different, not so different, but slightly different from other network infrastructure or digital infrastructure. First of all, when we talk about submarine cables, as you all know, we are talking about 25 years. So we are building something for next, it may be 25 years, it may be 15 years, but we are building that infrastructure for the next 25 years, which makes, you can imagine you are building something for next 25 years or 15 years, and you have to plan and think and design everything today. And you have to think all the consideration that, comes into picture, and that is something that you have to consider. The second important thing about, submarine cable, very different, it's the geographical spread. So when I'm talking of, we're discussing sitting in India, but my cable is going across the globe. And I can do something here in India, which we are trying to do, but something that is happening outside India, that's beyond my control, or, I have to somehow control that. So my cables are going from India, going to, Red Sea, going to Egypt, then going to Europe, and on the other side is going to, the Atlantic side and Pacific side. So I think it's the spread of submarine cables, the cables, I own the cables, I have investment cable, but from the control perspective, I think it becomes very difficult to control because the spread is very large. And again, as many panelists mentioned, it's a very niche domain, very limited vendor, we have OEMs, vendors, and they are marine service providers, very limited kind of, ecosystem, which makes very difficult, we have a dependency and, it's like a lot of dependency on that. So it becomes very imperative for us to develop that kind of capability, whether it's within India, keeping in mind the Viksit Bharat mission, or, somewhere, we have to have more vendor ecosystem where, we can have less dependency on less number of vendors, and sometimes that we get impacted by the geopolitical factors as well. And then next point is the complexity of the business and the commercial models. It's evolving very fast, and normally the regulations and laws, they are not able to, keep up to that speed. And the commercial and the business models are primarily driven by the, the business need and business requirement, the way technology is evolving. Whereas the regulation is always, little a step behind, which makes it really difficult. And, there were talks about delays in submarine cable projects, delays in getting approvals, the new concept coming. And that becomes, very important for us to keep those regulations at least aligned to the development that is happening in the market with respect to the business and technology. And finally, I think everyone is aware of the project complexity because of all these reasons. The huge cost, the timelines of the projects. I'm building a cable today, I'm planning a cable today, which will be built after 5 years, and I'm building for next 15, 20 years. It's very complex thing. And the timelines are very, long timelines, long time frames, and the operational complexity also is a factor because I have to run the cable for next 25 years once it's built. Building is one thing, and running the cable and operating cable for next 25 years is another important aspect, which is again a very complicated thing. The end of life, the marine operations, the permitting, there's so many things, complexity that comes into play. Now, for all these reasons, I think I'll get into the resiliency and robustness concepts. Some of those, concepts have been discussed. They are very familiar and very common to, entire, discussion that we had in the morning. The first and foremost, I'll be slightly talking a little different that there is need for more cables and more capacity. If you're talking of resiliency and robustness, and I link it to that, Viksit Bharat mission, it becomes important to have more cables and more capacity. And everyone is talking like in India is having only 18 cables compared to 400, 500 cables across the globe. I think we have some data points, and we know that, there is a requirement of multiple cable system, which is happening, but it will take some time. Diversity comes next, and we'll get into detail of the diversity we have discussed, but I'll, show some of the slides where, practical points in the diversity, what impacts us. The third important point, I think we missed out in the morning sessions and maybe in our discussion, the cable protections and smooth repair and maintenance procedure. Now, if I tell, many people will be aware, but if I talk about a subsea repair or there is a cable fault, it takes minimum 3 months to repair. In the morning session, I think Amarjit was telling about $50 per hour for the GPU sitting idle. Now you think if your GPUs are sitting idle for like 3 months, so you can compare the cost. So while you are talking about AI, and then the cost of GPU, and then the GPU sitting idle, and here we are talking about 3 months, and 5 months of submarine cable is down, and we cannot do anything. So cable protection, I think we need to avoid that. And Bombay and the western region of India is one of the hot spots from the India perspective, where we have many cable failures, multiple cable failures, they go down, they are not getting repaired for 3 to 5 years. And you can imagine how it will impact our AI mission and whatever you're talking in the Viksit Bharat mission. So it's very important that protection of this cable system and the repair and maintenance, the complexity, even if cable is cut, I think 1 or 2 months we'll be spending 1 or 2 months in getting the permits, bringing the ship, and getting those cables repaired. So that also becomes very, very critical from that perspective, that we should have very strong cable protection and mechanism, regulations, and very smooth and repair maintenance procedure, which is still complicated. A lot of things have happened. It has been streamlined, but we still need, when we are talking about 1 hour of GPU downtime, I think the repair should also be in the same line. And today, if I talk about some cable repair, which happens in 2 to 3 weeks' time, for me, for many customers, it's a miracle. And you'll be surprised to know if cable is getting repaired in 2-3 weeks' time, it's a miracle. So that's the way things are happening, especially in some parts of.
Soumya, unfortunately, we are already beyond the allocated time. So if you could
so
quickly wrap up.
Yeah, so I'm just finishing because the rest of the slides are very quick. And geopolitical consideration, that all we know about the geopolitics that impacts, so the subsea cables, and we talk of the Red Sea and other kind of failures. And finally, OEM and supply chain resiliency, and we talked about diversity of OEMs and suppliers. So that is, sorry, because I saw my screen and it was
Some of this
stuck
is not working. Yeah,
so
it was
anyway,
not-
I'll
it was
just to quickly finish in 1-2 minutes. So I think I discussed, this is just a graphical presentation of what I already discussed. We need to have more cables and more capacity. And this is a slide which I showed that many cables are getting retired. And within India, as we mentioned, I think we saw in the presentation, most of the cables will be retiring in next 5 years. So this becomes very important. I discussed about the diversity of the cable. And this slide shows the diversity in Atlantic and Pacific. This is a telegeography slide, where we can see the development over the last 10 years. And we said that these things will happen in India as well. There will be diversity coming up. Now, these are the 2 things which, from the resiliency perspective, I think there are some hot spots which we should avoid, especially, for example, there are known hot spots like the Singapore region, the Gulf state of Malacca. And then we have got, the Red Sea and the Egyptian network, where we have a lot of issues in terms of all cables going through them, and it impacts the resiliency of the cable. If one cable goes down, there are multiple outages, and that it leads to a majority of our traffic going down. I discussed about the cable protection and smooth RM process, repair and maintenance process. We discussed about geopolitical consideration, and especially in light of the Red Sea outage, where almost like 50-60% of all India traffic going to Europe was impacted, and it took 5 months. It's taking 5 months. The repairs are still going on. So you can imagine, cable out for 5 months. Now, in summary, I think most of the things we discussed. So proactively supporting new cables and diversity, that is a kind of recommendation. Then protecting submarine cables for a smooth repair and maintenance procedure. This has to be developed, and this will be the recommendation. Capability development in terms of technology, innovation, and skill set. I think this is another thing that we need to do if we want to make us resilient and robust sea network. And finally, collaboration with local and international stakeholders at various levels, considering the geographical spread and our cables going to different countries and different regions. It becomes very important to have government to government level interaction and industry interaction with multiple stakeholders. And this is the summary. Thank you so much for it.
Thank you so much, Jim. Let me now invite the last speaker for the session, Mr. Santosh Iyer, Head Enterprise, Bharti Airtel.
Good afternoon, and thank you all for being here. Am I audible? Thank you, BIF, for giving me an opportunity. I will try to be a little quick and try to give an industry perspective representing Airtel, which has been at the forefront of subsea cable deployments in India. Quickly, I'll start my presentation with a very simple data point. We all know that submarine cables carry more than 95% of the international traffic. If you look at the India perspective, India has 17 cables today, which is roughly about 3% of the global total across 14 landing stations. Most of the landing stations are in Mumbai and Chennai, as we all know, and there are landing stations in Cochin, Tuticorin, and Trivandrum. If we look at the international bandwidth growth, and if you look at the global projections, this is poised to grow at about 33% CAGR, which roughly implies that the bandwidth is going to double every 2.5 years. If we look at this by region, Africa is expected to have the largest growth, followed by Asia. Coming back to the India context, India, of course, is poised as a regional digital hub, primarily because of a geographical advantage, lying right at the center of the Indian Ocean. There is, of course, digital growth, and there are enough drivers around that. The data center market is exploding in India, and this is a space where the demand is going to outpace supply clearly. If we go by the industry estimates, the data center market is expected to grow 5x to about 8 gigawatt by 2030 and about 14 gigawatt by 2035. There are, of course, new submarine cables being planned, primarily by hyperscalers, but also by telcos. Thankfully, India is a space where the telcos are not retracting from this space. I mean, globally, in many markets, the telcos have stopped investing, or they feel that there isn't enough necessity for them to invest in submarine cables. That's not the story, at least, I mean, I'm talking about an Airtel perspective. We continue to invest in cables, and we feel there is enough demand driver for us, for our own captive requirements, and to serve to our customers. So, of course, hyperscalers and telcos put together are continuing to invest in cables, and we'll see a lot of cables coming into India, between 50 to 100 fiber pairs slated to come in the next 5 to 6 years, which if we go by the design capacity of 20 terabytes per fiber pair, this would be about 1 to 2 petabytes at a cumulative level. There are, of course, policy initiatives by the government of India. There's a lot of push on digital adoption and all of that. So India is well poised to not only be the regional digital hub, but also to catapult itself into a global transit and switching hub. That's on the demand side of it, but is the industry prepared in terms of robustness, in terms of resilience? I feel it's a very fragile ecosystem, both inwards within India and, of course, globally. If we look at India, and everybody has said that there is a concentration risk. 80% of the capacity lands in Mumbai and Chennai. And if we drill that down, if we look at Mumbai, it's a 6-kilometer narrow beach, Versova Beach. That's where all the cables land. So that's a potential choke point. If we look at Chennai, right, in about 150 meters of beach shore, you have beach manhole after beach manhole right next to each other. The front hauls run almost parallel on the same road. So that's a potential choke point as well. There are, of course, physical and natural threats. There is external reliance. India doesn't have a sovereign and autonomous repair system. And then there are, of course, permitting issues. The process is very complex. It takes about 3 to 5 months for any repair to happen. There isn't a single window clearance. Some of these things, we've already made representations to the regulator and DOT. So these are the vulnerabilities within India. Of course, if we look at it externally, the marine routes are common, as some of the speakers already alluded to. There are bottleneck regions. The Red Sea, of course, is a big geopolitical bottleneck at this point in time. Egypt, I mean, almost every cable potentially crosses Egypt. The Strait of Malacca, closer home, another bottleneck area, and of course the South China Sea. So all around us, we see bottleneck regions, and geopolitics is here to stay. So the natural answer is to build unique routes and be as diverse as possible. I'll quickly talk about 3-4 areas which the industry needs to focus on to build a robust and resilient infrastructure. First and foremost, diversification is the key. Decentralization is important. So if you look at the design principles, try to decentralize as much as possible, create new gateways. Thankfully, on the eastern side, Vizag is now emerging as an alternative to Chennai. And hopefully, we'll have an alternative on the west coast as well. People are talking about Alibag, maybe Mundra. Maybe in a year or 2 years' time, we'll have something coming up there as well. And then, of course, the need of the hour is to have more port cities coming up as alternate landing hubs. Probably some of them can also be positioned as strategic hubs. Long-haul and metro networks, these are equally important because hub-to-hub traffic has to be robust, resilient. That's a bit of a problem today. Most of the terrestrial networks are under stress because of continuous expansion. There isn't a very clear policy on how do we protect that infrastructure. People have started moving towards OPGW fiber, which is the fiber that runs along the power transmission line. But that's a scarce resource, so that isn't solving things as well. But with things moving to the CLS, edge and compute moving to the CLS as well, some of the problems will get solved. But even then, you need to have a very strong long-haul and metro infrastructure as well to complement the growth on the subsea infrastructure. Domestic submarine cable, this has been something that has been mooted quite a few times, but nothing concrete has come up. Maybe the industry, probably it's the right time for the industry to pick this up. A cable running along the coastline of India, connecting all key ports and cities, and maybe acting as an alternative to the long-haul terrestrial network. And of course, global routes, we'll see more and more unique routes coming up. The hyperscalers are building routes between Africa and India, Africa and Asia. Australia and India is a recent announcement as well, right? So cables traversing the globe, focusing more on unique routes is the need of the hour. And geographical dispersion and de-risk, of course, look at partnerships. That's very important because you can't do everything alone. Look at partnerships in the region. And Middle East is an area where a lot of countries are working in tandem. Maybe it's time for India to also explore some sort of a partnership in Southeast Asia. Unique bespoke solutions, bypass solutions, self-healing mesh networks. These are probably the network design principles to look forward to. Atmanirbharta in maintenance. This is equally important because today we don't have any sovereign repair capability. We are dependent on external vessels. An Indian flag vessel anchored in India is probably the need of the hour. I think, and that's a consortium that needs to be built. I don't think there is a business case for one party to probably go ahead and do it. And maybe with some government intervention and incentive, this probably can see the light of the day. Storage depots, equally important. And of course, business continuity, which means, your ease of doing business and reduction of your turnaround times and stuff like that. So these are equally important for the industry to focus on. Policy and regulatory reforms, this is a very important area, and we made several representations to the regulator and DOT. Declaring this as a critical infrastructure, of course, the telecom law allows it, so that is important in my opinion. Creating protection zones, maybe dedicated cable corridors with no fishing activity, that is something the government can probably look at. And of course, the single window clearance is the need of the hour. And of course, risk mitigation and security, which is sort of leveraging technology to defend the assets lying deep beneath. Physical security is important, so usage of sensors and stuff like that. Cyber resilience, equally important, and some sort of a geopolitical strategy where you are aligning with like-minded countries to ensure shared security. So these, in my opinion, are important for the industry to look at, and Airtel will continue to invest in cables, will continue to look at unique, diverse routes, will continue to ensure that we build a robust infrastructure in India. Thank you.
Thank you very much, Santosh. Thanks for taking just about the time you allocated to you. Although overall we are already 15 minutes beyond schedule, I don't know whether we can take audience questions. Can we? Oh, okay. Please. Arrange a mic.
Yes, sir. Sir, namaskar. I am Dr. Jagdish Shivahari, professor and ex-scientist, sir. My question, general question, what specific design considerations are needed for subsea cable infrastructure to handle multiple zones and regions with high availability and fault tolerance?
Anybody from the panel would like to address that?
Yeah, I think most of us can answer that. And I would say there's no simple one-line answer for you. The considerations which go for supporting a critical infrastructure are many, but the key ones are how to put the diversify route. That's the major one, first of all. The second one is what kind of armoring you want to do into the shallow waters versus deep waters from a design perspective. Third is what kind of repeater capabilities you will put into that system. And there are many good developments which have happened in the last recent years, which gives us capabilities. Next one is, should it be a 16 fiber pairs or 24 fiber pair system or more than that? And driver for that could be the stakeholders' interest or the per unit cost economics on that cable. And finally, which design can be deployed faster, because time is also a criteria and a cost is a criteria as well. Sure. So if you want best of everything, but it will come after 1 or 2 years later, it may not be the right answer for you. No. And there could be even more consideration because the application of one hyperscaler may not be exactly same as a second hyperscaler as well, because their global architectures could be different. So, and we're happy to talk more, and there are good friends here who are building here and can share.
Thank you, sir.
Thank you.
Thank you, Ashish,
Yeah,
for the response.
Mr. Chairman. Yeah.
Yes, please.
Yeah, one more question on similar lines. So as we were talking about how to lay down the fiber cables, I wanted to talk about seismic risks. It was covered in one of the presentations regarding there are earthquake activities that can be there and that can cause a risk to the submarine fiber cables. But interestingly, we also hear about sensors that can help us detect warnings of these warnings of these earthquakes or tsunamis coming up. So how do we balance that? And can earthquakes really impact the submarine cables so much that they cannot act as a sensor to give us warnings for these tsunamis coming up? So this is one of the questions there. And sorry, I'm Richa from Cisco Networking.
Thank you very much. Anybody from the panel would like?
So I think, I did cover, India at one point in time was on the verge of getting isolated, both because one was the tsunami and earthquake in Japan, 2011 and 12. Then we had a sabotage activity in Red Sea, and that's what we have been talking about how do we bypass, Red Sea, for example, Baltic Ocean in Europe. We talked about Singapore as well. To answer your question, if you look at the recent announcement made by Google connecting WISEC to US via Australia, those are the options available because you need to look at, you can't avoid a seismic zone. Around Japan, you'll have a seismic zone. So question is, how do we diversify the cable laying process and where all you want to touch upon actually? So that's the answer. Second is, I think Ashish covered the sensor part of the story, and that's a critical one. I'm not the expert on sensor, but picking up the signal, especially in advance from the sensors and helping to safeguard either your infrastructure or safeguard the capacity will be critical for the operators.
If I may add to that, to be more precisely, this awareness has gone multiple times in the recent times. So today, most of the turnkey suppliers are trying to work on smart cables per se, in which we dedicate a fiber pair or some channels to do purely the seismic activity monitoring for that purpose. Secondly, there's a DAS-based technology, which is only working on the shore side of the story for going up to a few hundred kilometers. It's not yet mature for thousands of kilometers to sense the activities. And then the project by the seismic agencies in India itself, which we are talking, whereby they want to put the physical observatories under the ocean for the few hundred kilometers from the coast. That can come as a hard-coded seabed story. So to shortly answer, there are few technologies already available. Space is maturing, and everybody wants to leverage this data along with the commercial optical traffic to flow under the bed right now. And you will see a lot more happening in the next couple of years on this one.
Thank you, Neeraj and Ashish, for addressing a little bit sensitive topic around this. Yeah, welcome.
Hello, everyone. I'm Dr. A.K. Shrivastava, ex-DOT. I'm now a visiting professor with other institutes. My simple question is that because once the bandwidth requirement is increasing very day by day, the day are not far away when we'll have more than 1 petabit per second, So then for that particular, we have to make the things more resilient and more, it has to be both the cyber and also the physical attack has to be taken care of. My question is, what type of the fiber, because the G652D may not work over there, are you going to have a different type of the fiber, number one? The second number is, do you have to have the quantum cables for that, for taking detection of the QKD and all those? And third one is, at what layer will we using the AI and ML to take care of all types of the faults quickly and repair thereof? 3 questions.
Thank you very much. Somebody can address that? Right, okay. You see, there is a lot of development taking place globally around the photonics of the cable system. And as I mentioned in my presentation, there are 3, it's not just the one component that needs to be brought up in terms of supporting the higher capacity that everyone wants the submarine cable systems to support. There are 3 components that need to work together. One is the fiber itself inside the cable. The second is the repeaters that enable long-haul transmission. And third is the terminal equipment. So all these 3 need to work together in order for that to happen. Theoretically, photonics allows limitless traffic. Theoretically, there is no limit in terms of the capacity that can be supported by the photonics. But there are other components, as I mentioned, and there are areas regards to the physical space also that's available for the various components required to work together to be accommodated within the wet plant. The dry plant, there is no such limitations as such, but the wet plant also has a physical limitations, given the fact that it works under very, hostile environment under the sea and has to function for decades. The repair of any fault in the wet plant, particularly the electronics, is not an easy thing, very expensive. So all these things there have to be considered and balanced out when we go and develop the enhancements required for enabling high transmission in any submarine cable system. I think if I go into the details of the technical aspects, I think that will bore the audience, but this is something I just wanted to present as the key aspects towards developing more capacity within the submarine cable system. It's happening. 1 petabyte cable is already available, by the way. We are talking about beyond 1 petabyte. I hope it answers.
Sir, we have a lot of rumbling tummies now. We're just waiting for lunch to start. And I request those to park their questions for lunch. Please take them up on a one-on-one basis. Please give a round of applause to all our speakers on stage. We want to thank them for their presentations and for sharing their knowledge with the audience. I request our session chair, Mr. Ashutosh Zuchi, to please present mementos to the speakers. Memento for Mr. Philip Ng, Network Development Manager, Meta. A memento for Mr. Ashish Ahuja, founder and CEO, Shloka Partners, USA. A memento for Mr. Neeraj Sonkar, CTO, Constill. Memento for Mr. Anish Kohli of Telstra. A memento for Mr. Shomesh Kaur, AVP and Head, Subsea Cables and Satellite Operations. And a memento for Mr. Santosh Iyer, Head Enterprises, Bharti Airtel. I would request Mr. Atul Jain and Mr. Devashish, Additional Director General, BIF, to please come up on stage for a group photograph. And I request all our speakers on stage to please gather in front of the tables for a group photograph. We will head into a lunch break, and I request all of you to please be back in your seats by 1:45 when we will resume with our sessions. Do take this time to catch up with your friends over lunch and connect, perhaps take up the questions that you wanted to ask during the sessions. See you soon at 1:45.